So now we're going to learn about quicksort. Quicksort is something we can use it for sorting a random number in a way of divide and conquer, right? So if you look at this random number, instead of just selecting it or uh, inserting it or something, we can just pivot on one number, like at the end of the number, like 7 right here, and we can divide it into two. Now, on the left side, it's less than 7. On the right side, it's going to be greater than 7, and that's how we're going to sort it. So this way we're going to partition it first, and after that, make sure that we're going to re-pivot a new one on the left and sort it in the middle and put it in partition it, and then also we can sort it on the left and the right, and that's how we know everything is sorted properly. So this way is more quicker and faster than selection and insertion. Similar to this, we can apply it on the right side, the larger number that we pick up on the later. And so yeah, there's one step, partition it first, and then the second one is we quicksort it. So we divide it first, sorry, and then we conquer it. So that's quicksort for you. And now we're going to look at the code. So here in the Python, let's say we have something, a data that we randomly pick, right? So the random number is 10, 15, 12, 1, 2, 5, and 7, right? And now we're gonna print the number C, and we're going to quicksort the number. So that will be something along like this. We will start from 0 and then end it the length of the data, -1, so we don't have to hit the last one. And then we will have a quicksort here. So that will be, let's just say data start and end, and then we will have a partition. So that will be similar to that. And now we're going to sort the left side and then sort the right side. So yeah, and before that we have to partition. That means we have to divide it, right? Yep. So we will collect the index of the number that we pivoted. So that will be that, and that's how we're gonna call. Okay, and now we will sort. We will just recursively call the quicksort right here. So we will start it from the 0, and then just right after the pivot index, right? That's how we're going to do it. And we will start it right after the index. So this one is right before, this one is right after, so that's where we start, and we will end like the way we end. And after that, this is how we're going to quicksort it, right? Okay, now we're going to partition it here. So what's happening in the partition is we will pivot the index, and then we will have a pivot value. So and we're going to start from the start. Why not, right? So in this case, we will have to compare how far we're going. If we don't know how far we go, then we can end up over the bound. And at the end, we can return the index of the pivot, which is n. After that, we will, so this will be all the data, right? So, and then before we have to put the positions the right position. So we have to swap it before. So pivot index value be inside data. So that's how. Let's just say, and then so it will swap them, right? And that's how we're gonna swap. Okay, now oh, we forgot something right here. We have to check if the element is only one, and then check if element is already sorted, right? So that we don't have to sort it. If start is larger than or equal to, and then we just return nothing because it's already sorted and we don't have to fix it or resort it again. Okay, now sort. Oh, and if start and index are not crossing each other, then swap start and end. So this one will be after we find the number between the pivot. So we're gonna swap it. Swap. That will be this. Oh, it's just, yeah, sure, why not? Like this, and then like this. There you go. Or we have to put in under if conditions. So if we still have a number like that, okay, and then right here we have to find the number between. Okay, so find number greater than pivot value, right? So how are we gonna find it? This start is still less than the length of the data, and still, and if it's equal to or less than. Yep. So pivot So pivot value greater than equal to data, and that will be start here. So what that means is that just continue the start index until we find something that the start index is greater than the pivot value, right? Now, since we started from the end, we will find something that is so something like this. So what that's saying is if the n is still greater than the pivot value, keep going. So this is the same, and see if we can find a number that is less than the pivot value. And after we find it, we will see if they are crossing each other. If they are not, we will swap. And here we will put the right position, the pivot value, in the last moment for the partitions. And then we will return the index, the pivot index that we put there for the new pivot index. Yep, that will do it. Okay, we've got anything? Nope. Okay, let me save it and let's print it. Oh, we got an error. Okay, let's see what's going on. Alright, we make a big mistake right here. So this is supposed to be the index, and I'm giving the value. So this is supposed to be like this, okay? And that's the index, so that will go to here. So let's see. Yay! Now it's sorted. 1, 2, 5, 7, 10, 12, 13, right? So now it worked. That is it for the quicksort. And this is complexity time is basically O log n and log n.